Hey, I want to solve problem number 71 from chapter 23 because it involves some integrals. And I thought that if I do them in front of you, you will have a better idea how to do the integrals. So let's go ahead and do problem number 71 from chapter 23 from the book Serway. All right? Okay, so as you can see, the problem is this one. You have a semicircle over there. It says a line of positive charge is formed into a semicircle of radius r, which is equal to 60 centimeters, as shown in the figure. The charge per unit length along the semicircle is described by the expression lambda is equal to lambda naught cosine theta. The total charge on the semicircle is 12 microcoulombs. Calculate the total force on a charge of 3 microcoulombs placed at the center of the curvature P. Okay, so the things that we have over here, for example, we have lambda is equal to lambda naught cosine theta, right? And we have this semicircle over here. From here to there, it's theta. This is r. This is the y-axis. That's the x-axis. Okay? So right now, I do not have lambda naught, but I am given the total charge. What is the total charge? It's equal to the integral of dq, right? What is dq? dq, if you consider this part as a small part of the semicircle, you can say that that length times the linear density will be your small amount of charge that you have over there. So this dq can be rewritten as lambda times ds. But what's ds? ds is equal to r d theta. Remember that r theta is the arc that theta covers. So dq is lambda times this ds. I'm going to rewrite lambda in terms of this. And ds in terms of this. So my total charge is equal to the integral of lambda r cosine theta d theta. Lambda naught and r are both constants, so I can take them out of the integral. I'm left with the integral of cosine theta d theta. But now, see that the theta is going from where to where. If this is theta equals to 0, then here it's minus pi half, goes to 0, and it goes to pi half. So, the limits of my integral should be minus pi half to plus pi half. So q is equal to lambda naught r. Now what is the integral of cosine theta? It's sine theta, right? We put it in the brackets. Now we have to calculate it at the final position and then subtract it from the initial position. So it's sine of pi over 2, which is 1, minus sine of minus pi a half, which is minus 1. So your total charge will be equal to, this is 1 plus 1, it will be 2 lambda naught r, right? which is equal to, I'm given the number 12 microcoulombs. And I'm given that R is equal to 60 centimeters, which is 0.6 meters, right? Therefore, I can solve for lambda naught. If you solve for lambda naught, you will get that lambda naught is equal to 10 microcoulombs per 1 meter. Now we have lambda naught, and we can go ahead and calculate the electric field at point P. Remember, the question is asking for the force on a charge, but to get that force, we first need to find the electric field at point P. Then we will get F equals Q times E to get the force acting on that charge. Now let's first of all see where R hat is. Why? Because for the electric field, we need to do an integral of K dq over R squared R hat. So this R hat is important right now. First, let's figure out what R hat is, then we will do the rest of it. R hat, in this picture, you can see that it's at where you are, the point charge is over here. It's a small amount of charge, that's what we can consider it as a point charge. So if this is your point charge, the electric field should be away from that. You connect this part to where you're sitting at, your R hat will be away from that direction, okay? This will be your R hat. But, as you can see, there is a relationship between this R hat and this theta over here. So, for example, let's consider a normal R hat, which is going in a unit circle. In a unit circle, if your R hat's going that way, remember that the magnitude of R hat is 1. Since the radius of the unit circle is 1 as well, I can consider it that way. If this is theta, if this angle, I'll call it alpha. I'll call it alpha. If this angle is alpha, then cosine alpha I hat plus sine alpha j hat will be equal to R hat. Why is that? Because this is cosine alpha I hat, and this is sine alpha j hat. So when you add these two vectors, you will get R hat in this direction. Now, to get the feeling for this guy, first we need to be careful. This theta is actually equal to this angle over here. See? This line and that line are crossing each other, this line and that line. Therefore, this angle is also theta. As you can see in this one, when you when you do cosine of theta, it will be into the negative y direction. So in here we had cosine alpha in the I hat direction. In this case, cosine theta, which remember in here, this is theta, right? This is a positive number. So when we do cosine theta, minus that will be in the negative y direction. So our R hat actually will be equal to minus cosine theta j hat. And if you do a sine theta, it's going into the negative x direction. So minus sine theta j I hat. I'm sorry. So minus theta I hat plus minus cosine theta j hat will give you the r hat. This might be a little confusing, but if you do a unit circle, you will find out that this relation is correct. Minus theta I hat, which is in the negative x direction, minus cosine theta j hat will give you the r hat. Okay? Now let's rewrite our integral over here. E is equal to, let's take the k, which is a constant, out of the integral. Rewrite dq in terms of lambda ds, lambda ds, which is r d theta, right? Divided by, what's r squared? R is staying the same for all of these parts on this semicircle. So will be r squared. For r hat, I'm going to replace these guys, minus sine theta I hat minus cosine theta j hat. In here, we had cosine alpha I hat, sine alpha j hat for r hat, right? This r hat over here, this r hat seems to be exactly opposite this one, right? It's like I have flipped. Flipping these can flip sine and cosine, and also a minus sign. Actually, the flipping is give you the negative. Flipping of sine and cosine is there because theta is considered from the y-axis. In here, alpha is considered from the x-axis. So because of the geometry of our problem, that's bringing the confusion over here. Okay? But because I want to be consistent with the problem, that's why I need to derive this r hat over here. Okay? So now let's continue with this. E is equal to k. Now lambda naught r cosine theta, because lambda is lambda naught cosine theta, d theta over r squared, and my r hat is sine theta I hat, I'm sorry, minus sine theta minus cosine theta j hat. Okay? One of these r's will be cancelled out with the power. It's equal to k. I can take this r out of the integral because it's a constant. It's not a variable. The integral of. Now, this multiplied by these two. And also, where am I integrating from? I'm integrating from here to there. But theta at 0 is here. So I'm integrating from minus pi half to plus pi half, right? If this is 0, that's minus pi half to plus pi half. Now multiply these, so minus cosine theta, sine theta, minus cosine theta, sine theta. I hat, that's one of them, minus cosine squared j hat, minus cosine squared theta j hat. at the end, d theta. Okay? Now, the only thing that you have to do is to separate these integrals and do them one by one. Now, here's the thing. When you're integrating a function from minus a to plus a, if that function is an odd function, that integration will be 0. So because cosine times sine is an odd function, then the integration of minus a to plus a of that function is equal to 0. If you don't know what odd functions and even functions are, you can simply look this up and do the integration yourself. So I rewrote this equation on another page, and I have gone through the math appendix in your book. So to get this integral, I will first look for any way to make this simpler. So sine theta, cosine theta is equal to sine of 2 theta over 2. That's because 2 times sine theta cosine theta is equal to sine of 2 theta. So divide both sides by 2. So I can replace this guy over here. Also, that's the equation I used over there. It's on page A12. Okay? There's another equation I can use. Cosine theta squared is equal to 1/2 of 1 plus cosine of 2 theta. Okay? I'm going to use these two equations. If I do, E will be equal to K lambda naught over R integral minus pi half plus pi half. Now here, minus sine of 2 theta divided by 2 d theta I hat. Don't forget that these I hats and j hats are very important. Minus the integral of minus pi half till plus pi half. Now instead of that, I'm going to put 1 plus cosine of 2 theta divided by 2 d theta j hat. Okay? Now, again, K lambda naught over R. Now, the integral of minus sine is cosine. So cosine of 2 theta. But I have to divide that by another 2. I'm doing anti-derivative. So if I take the derivative of this, I have to take the derivative of 2 theta first, which is 2, which will be multiplied over here. So 2 multiplied by this will be this thing half, because 2 will be simplified with 4. It will be half. And derivative of cosine is minus sine. So this actually is the antiderivative of this guy. Okay? I have to calculate this from minus pi half to plus pi half. I hat, again, put the I hat over there, minus. Now, the integral of, actually I will do a minus. Minus integral of 1/2 d theta is actually theta over 2, right? And the integral of cosine of 2 theta over 2 is plus sine of 2 theta over 4. J hat. Okay? So I have to calculate cosine of 2 theta at pi over 2. So pi over 2 will replace theta. So I have to do cosine of pi. Cosine of pi. Let me go to the other page. Okay, so I rewrote this. K lambda naught over r. Cosine of pi, because the 2 cancel out, will be minus 1, minus cosine of minus pi, which is again negative 1. Okay? Minus. This will replace this, so it will be pi over 4 minus pi over 4. Plus sine of pi, which is 0, minus sine of minus pi, which is again 0. Right? This is equal to K lambda naught over R. Now, minus 1 plus 1 minus 1 plus 1, this is 0. These are 0. This is pi over 2. So minus pi over 2. A thing that I forgot to put there. This is I hat. This is J hat. This was I hat. This was J hat. So for I hat you had 0. For J hat you have this. So our electric field, final answer, K lambda naught over R minus, pi over 2 in the minus J hat direction. That means that on that semicircle, the E field is pointing in the negative Y direction. It makes sense because whatever you see here, if the E field caused by this guy is this way, the E field caused by the other side of the circle is that way, the X components cancel each other. The only thing that remains is the negative Y direction. So that's the electric field. For the force, all you have to do is to multiply the charge of that thing by the electric field. Okay? So we had, I think, 3 microcoulombs. Let me bring that question again. We had 3 microcoulombs. It's over here. So 3 times 10 to negative 6. Now for K, 9 times 10 to 9. For lambda naught, it was 10 microcoulombs per meter divided by the radius, which is 0.6 times pi over 2 in the negative j hat direction. Okay? Okay, so I just did the calculation, and the final answer that I got is 0.706. Okay? Remember that it's in negative j hat direction. That's the force I got. Now, let's check with the final answer. Chapter 23, 71. It says minus 0.706 in the I hat direction. I think this is a typo. It should be j hat. Because clearly, if you sit on here, the electric field caused by this semicircle, because of the symmetry, it can only be in the y direction, because the x directions will cancel each other. So in here, if I have something from here and something from here, my drawing is terrible, but you know that if their angles are the same, if the distance is the same, there will be these two added together, head to tail, okay? It will be purely in the negative y direction, okay? So the x components cancel each other. The only thing that remains is the y component. Okay? If you have any questions, send me an email. Okay? Thank you.